In this video, we're gonna try to prove or disprove a result concerning some integration. When we ask about proving or disproving, we're trying to, most of the time, finding a counterexample that will show that our result might be or it is false. If it's true, then we can have some proof of it. If we can find a simple example that will show us that the result is false, then the result is false for all the rest. In our case here, we are trying to prove that this double integral here is equal to 1 over n plus 1, the integral between 0 and a of f of x dx. Well, let's assume that we can find something, but sometimes the simplest things are the most beautiful things. We can find something easy. I can't choose a simpler function than 1, because if I choose 0, then I'm gonna have 0 and I'm done. So this is true, but it's not in my point of view. So the easiest way is to find a simpler function, and I think the simplest one is if I choose f of x as 1. Okay, once I do so, this left integral is going to be the integral between 0 and a and of f of x, which is 1, and here f of t is just going to be 1, and therefore I have the integral between 0 and x of dt to the power n dx. And on the right side, I have 1 over n plus 1, the integral between 0 and a of f of x, which is 1, so I have dx. So the right side is the easiest one. Here I'm integrating 1 between 0 and a, and therefore I have 1 over n plus 1, and my primitive in this case is x between 0 and a, and therefore I have, when I evaluate, I'm going to have a over n plus 1. So if this is true for x equals 1, then I should get the same thing here on the left side. Let's see what we get. I have the integral between 0 and a, and here when I integrate, I'm going to get 1 or x or t between 0 and x raised to the power n dx. Let's focus on this part here first. Okay, so once I do that, I have the integral between 0 and a, and once I do evaluate t between x and 0, I get x to the power n dx. Because remember here, I have t, I'm integrating with respect to dt, therefore I have t, and I'm evaluating t between 0 and x, so I get x minus 0, and I have this power n, so I have x to the power n dx. Now I'm gonna use my power rule integration, so I have 1 over n plus 1 x to the power n plus 1 between 0 and a. Okay, if I keep working, I'm gonna get 1 over n plus 1, and when I evaluate, I'm gonna get a to the power n plus 1 minus 0. Therefore, the left side is gonna be a to the power n plus 1 over n plus 1. Should it equal a to n plus 1, which is the one on the right side? Are these quantities the same? No. Okay, it might work when a is 1, but we are doing it for a general a. So this proves that this one is not true. Okay, and we're gonna see how to make it true in one of the videos. But for now, to prove or disprove something, to disprove it, find a simple counterexample. To prove it, sometimes results take a lot of years, or maybe there are still open results or theorems that we can't prove or disprove. But for us, a simpler example would make the work. Okay, If you want to do one more, you can take f of t as x in this case and see what you get. Okay, it's not gonna be that much of the work, but on the right side it's gonna be a squared over 2 times n plus 1. Okay, and here it's gonna be x to the power n plus 1, and we'll get 1 over n plus 2. And this again, if you want to do it, proves that this result is false. Okay, thank you very much.